I am Dr. P.V. Thokar, Department of Electrical Engineering, Sanjuni College of Engineering, Kopargaon. I welcome all of you for today's session number 4, which will start from the point medium transmission line. As you are aware that in case of medium transmission line, in this particular type, there are three methods. The number one, end condenser method; number two, nominal T method; and number three, nominal pi method. So first method for medium transmission line is end condenser method, second one is nominal T method, and then nominal pi method. So starting with the point number one, end condenser method, the diagram is again same what we have seen in the previous sessions. First is resistor, then inductive reactance, load, they are connected in series. Vs stands for sending end voltage, sending end current, capacitor, Vr, and XL. Now let IR is the load current per phase, then R is the resistance per phase, XL is the inductive reactance per phase, C is the capacitance per phase, cos phi R is the receiving end power factor which is lagging, and Vs is the sending end voltage per phase. After considering these particular points for end condenser method for medium transmission line, as I already explained you that in case of short transmission lines, capacitance is negligible. That is why for short transmission line we have not considered the capacitor. But in case of medium transmission line, for the first method, condenser method, in condenser method, capacitor is connected in parallel with the load. Now it is very important to draw the vector diagram for this. So for I will explain the vector diagram, how to draw the vector diagram for this particular end condenser method. So starting with the point number one, we will treat voltage vector, or we will take voltage vector as a reference vector, or considering this point, voltage vector as a reference vector. So let us consider phasor diagram for end condenser method. Now starting with, let us take voltage Vr as a reference vector. Okay, then IR, this is vector IR, which is lagging to Vr by cos phi R. Now as okay, then if you considered in this case for pure capacitive circuit, as capacitor is over here, this capacitor is connected to the load. So what happens, it is treated as a pure capacitor, and for pure capacitor, if you consider the voltage and current vector, current leads to the voltage by 90 degree. So same case we will consider over here. So in this case, the capacitor, instead of considering the capacitor current as I, here we have given the notation as IC. So we can also add over here, IC is the capacitor current. So here I can make the change as IC and VR. So same change, IC leads VR by 90 degree. Same reference I will consider for the vector diagram. So here I will take this vector. I will draw this vector for IC, right? Now IC, same IC will draw over here, and we'll get IR plus IC as a new vector. That is IS. Now we'll consider the loss, sending end loss. IS is in phase with IS into R. Then we'll draw IS into XL 90 degree. Then these 2 points will be IS into Z. And now if we connect these 2 points, we will get VS. This is VR, vector VR. Now the angle between VS and IS, this is phi S. This angle between voltage Vs and Is is phi S, and angle between Vr and Ir is phi R. So this is the phasor diagram for N condenser method. Now from this we can write the various points, like here vector Vr is equal to Vr plus J0. Then load current is IR or I, and it is written as IR cos phi R minus J sin phi R. Then we can write capacitive current is IC bar is equal to J into VR omega C, where it can be written as J into 2 pi FC into vector VR. Vector IS can be written as vector IS is vector addition of vector IR plus vector IC. Now from this thing, vector IR is already mentioned over here, so we can write IR cos phi R minus J sin phi R plus IC, we have this value for IC, this value IC is J, we'll take this value into 2 pi FC into VR. So after solving this expression, we can get IR cos phi r plus J into minus IR sin phi r plus 2 pi FC into VR. This is what IS is. Then voltage drop per phase, voltage drop per phase is equal to IS into Z, where IS bar into IS bar into Z bar, where Z bar is R plus J XL. So this is for voltage drop per phase. Then next point, considering sending end voltage, sending end voltage can be written as Vs bar is equal to VR bar plus IS into Z bar, IS bar into Z bar. So here Vs is written from Vs bar is equal to VR bar plus IS bar into Z bar. So vector sum of VR and IS into Z is Vs. So from this vector diagram we have written vector Vs is equal to vector VR plus vector IS into Z. Here it is written as VR plus IS bar into Z is R plus JXL. So this is what Vs bar, that is sending end voltage. Percentage voltage regulation is equal to Vs minus VR divided by Vs into 100. And voltage transmission efficiency, that is percentage voltage transmission efficiency is equal to power delivered per phase divided by power delivered per phase plus losses per phase into 100. So it can be written as VR IR cos phi r divided by VR IR cos phi r plus IS square into R into 100. See, so this is all from my side. Thank you.